Hi, this is Shai Liang, and doing the homework 9. The net ID is sl5352. The first question asks us to suppose W is a stochastic process with an expectation equals to 0 and correlation equals to alpha times minimum value of a T1 and T2, and define Yt as a difference of a T and W W valued in T and T minus 1 for T is greater than 1 and 0 for T is less than 1. So find expected value of a Yt and autocorrelation of Yt and find if Yt is a White-sense stationary process. First question is the first question here we asked to find the expected value of a y, which is nothing but expected value of a wt minus 1, which could be the expected value of individual ones, and thus give us an all 0. So the final answer is 0. And the second one is to find the correlation of a y valued in time t1 and t2, and we could write an expansion here as and then expand this polynomial with with autocorrelation of r w valued in t1 and t2, r w valued in t2 and t1 minus 1, and the same vice versa, and so on and so forth. So it's alpha times a, and which alpha is a one we extracted from here, and to add with some minimum value of a t1 and t2. So next process, this intuitionally gives us an a could be something that related to time, which is represented r or w is not a White-sense stationary process, but we need to check if it's right or not. So given the condition that t1 is less than t2 minus 1, which means that the correlation for y t1 and t2 is nothing but t1 minus blah blah blah. This polynomial is given by the minimum value, so so on and so forth, which is on the same condition that the t2 is less than t1 minus 1, and the same one, r is equals to 0. Next condition is that the t2 is greater than t1 minus 1, but the less than t1, which yields the final consequences over here, and the same as t1 as there. So gives us the difference of a time, which doesn't necessarily matter with the starting time of t1 or t2, and this leads us to draw the conclusion that the y is a White-sense stationary process. That is pretty much about question number 2. Oh, question number 1, sorry.